All right, you are welcome again. Today we want to talk about a very interesting topic in physics called relativity. Okay, so what is the meaning of relativity? When you hear the word relativity, what comes to your mind? So I'm going to explain this in a layman understanding. So relativity simply means the study of how observers in different reference frames measures the same event. Okay, you see, two observers in different reference frame measure the same event. But what is a reference frame? So reference frame is talking about a particular location that someone is making observation from. And then reference frame is the same as frame of reference. It simply means where you are and how things looks to you. How things looks to you. Okay? Now, for instance, someone by the roadside beside a tree sees a vehicle as a moving object. And then someone in a vehicle sees the tree outside as a moving object. You get it? So someone outside the car sees the car as a moving object, and then someone in the car sees the object outside as a moving object. That is how things look to you. Okay? That is what we call reference frame. And then the study of how observers in different reference frame measures the same event is what we call relativity. So here that means we have two observers, observer at rest and then observer in motion. So we're going to call observer at rest O, and then observer in motion O prime. So anything concerning observer in motion is going to have prime attached to it. Okay, good. Now, what is proper length? What is proper length? Proper length, L0, let's call it L0, is the distance between 2 points measured by an observer who is at rest relative to both of the points. Now, when we're talking about length, length is the distance between 2 points. Okay, good. Now, this distance between 2 points is measured by an observer who is at rest. So this length is called proper length because it is taken by an observer who is at rest. So now, let's go further. That is to say that if an observer who is in motion measures the same length, it's not going to be the same. So the difference, there is going to be a decrease. So that decrease that is in this length because the observer is in motion or the object itself is in motion is what we call contracted length or length contraction. So we say that length contraction is the decrease in observed length of an object from its proper length L0 to length when its length is observed in a reference frame where it is traveling at speed v. Okay, so an object which is at rest or an observer which is at rest measures a length. The measure is not the same as an observer who is in motion or object that is in motion. Okay, so the difference, there's going to be decrease. Okay, there's going to be decrease from the observer in motion. So that decrease is what we call contracted length. So contracted length can be given, let's say contracted length is L. So L is, or it can be calculated. I will say that it's going to be the proper length L0 times square root of 1 minus v square all over c square. Okay, yeah, Now, it's the same thing as saying L naught all over gamma. Now, this gamma is called Lorentz factor. Okay, this is what causes the what? The difference. You get it right? Good. Now, we have seen what proper length is and what contracted length is, right? Good. Observer in motion and observer at rest. They are not going to measure the same thing. So the difference, there's going to be a decrease from the observer in motion. So that decrease is what we called length contraction. And then the original one measured by an observer at rest is called proper length. Okay, good. Now let's go. What is proper time? Now let's denote proper time with this. Okay, now proper time is the time interval measured by an observer who sees the beginning and end of the process that the time interval measured occur at the same location. That is proper time. Now, what is time dilation? Time dilation is lengthening of the time interval between the two events when seen in a moving inertial frame rather than the rest frame of the event. That is to say, there is an event and someone takes the time of the event from the beginning to the end, and that observer is at rest. So the timing taken or measured by the observer at rest is called the proper time. Okay, so and then we say that another observer is in motion, so taking the same measure of the event, so it's not going to be the same time. Okay, it's not going to be the same time. So there will be a lengthening. That is the time measured by the observer in motion is going to be more than the time measured by the observer at rest. So that lengthening, that increase is what we call time dilation. So now we can simply say that time dilation is the proper time all over square root of 1 minus v squared all over c squared. Okay, the time dilation is given as the proper time all over square root of 1 minus v squared all over c squared. Okay, good. Now, what is inertial frame of reference? Inertial frame of reference is the reference frame in which a body is at rest, remains at rest, and the body in motion moves at a constant speed in a straight line unless acted by an outside force. Okay, so now we've talked about proper length and length contraction, and then proper time and time dilation. What can we say about length at rest and length in motion, or length measured by an observer at rest and then length measured by an observer in motion? What can we say about it? So we will say that length at rest is greater than length in motion by definition. Length at rest is greater than length in motion by our definition, right? Good. Now, what about proper time and time dilation? So we say that time in motion is greater than time at rest. Hello, time in motion and time at rest is not gonna be the same. All right, yes. So here is just an introduction to relativity. We say what relativity is all about: time dilation, proper time, and then we talked about proper length and then length contraction. Okay, so in our next video we're going to take some exercises or some examples. Let's see how we can calculate proper time, time dilation, proper length, and length contraction. All right, yes, see you in the next video.